Hello everyone, my name is Yukthika Boddeda, and today we'll be looking at NMR titration and perturbation. NMR titration is a method used to study protein-ligand interactions and to measure binding affinity of different binding factors through measuring chemical shifts if residues present in the particular spectra or experiment. Here, I have spectra for a particular experiment opened up in front of me, where each spectra represents a different molar ratio of the binding factor. For example, UBCH5 is where the molar ratio of the binding factor is 0, and then 1, 1, 1, 2, 1, 4, and so on. As you can see, if I hover over one particular residue, let's say L104, the chemical shift in nitrogen is 119 ppm, while that of proton is 8.377 ppm. As you can see, the chemical shift of nitrogen is way larger than the proton chemical shift, and in order to account for this particular difference in chemical shifts between nitrogen and proton, there is a formula devised to adjust or compensate for this difference. But in order to explain the importance of considering that difference, I'm going to go ahead and generate a perturbation plot without taking into consideration that difference, and I'll show you why that is wrong. First, I will go to POKY, then I will go to perturbation analysis and generate a perturbation plot, or simply type the two-letter code NP. Then I'll choose the two spectra or two molar ratios that I'll be comparing. I will be selecting the molar ratio 0 and molar ratio 1, 1, but you could select whichever two you would like to look at or analyze. And your X label will be residue number, and Y label will be CSP, or chemical shift perturbation. And in observables, as I said, I'm only going to go ahead with proton chemical shift and not consider nitrogen chemical shift just to see what happens. Then I'm going to click Analyze, and it's going to pull up all of the different chemical shifts that will be observed between these two spectra. Then I'm going to click Plot, and it should pull up a perturbation plot here. As you can see, the Y label will be your chemical shift perturbation in ppm, and your X label will be residue number. And as you can see, there's positive and negative values, but however, negative values are not possible when you're trying to look at chemical shifts between different residues. So I'm going to go ahead and close this since that's not the plot I'm looking for. And then what I'm going to change here is go under observables and keep scrolling until I find this particular formula where DH is a proton chemical shift, DN is a nitrogen chemical shift, and that is all divided by the factor that compensates for the difference or huge gap between the nitrogen and proton chemical shift. I'm going to go ahead and click that and click Analyze again. It'll pull up all the chemical shifts, and as you can see, all of them are positive values. All the chemical shifts of the different residues are all positive. Then I'm going to click Plot again, and now it'll pull up a plot with all positive values, and these are all the accurate chemical shifts of all the different residues between these two spectra. And again, the Y label is a chemical shift perturbation in ppm, and X label is your residue number and all the different residues you're looking at between these two spectra. Then I'm gonna close this. Now, we'll be looking at how to generate a titration plot for the same experiment at the same different molar ratios. To do that, I'm going to go to POKY, Perturbation Analysis, and generate an NMR titration plot, or simply type the two-letter code NI. Then this pop-up will show. Here, our X label will be our molar ratio and Y label will be our chemical shifts. And then out of our resonances, I'm just going to choose a random or one specific residue that we'll be looking at. I'll be clicking on I6H, but you could choose whichever residue you would like to analyze. And here, all the different spectrum, as mentioned before, are the different molar ratios of the binding factor. So first you have UbCH5 for the molar ratio, the binding factor is 0, so the X position stays 0, and I'll click append. Next, we will pick the next molar ratio, which is 1, 1, so the X position will be 1, and append, 1, 2, half, append. I will go ahead and do that for all of the different spectra. Once I have that, this shows all the chemical shifts of this particular residue I6H between all of the different spectra. So I'm going to go ahead and click plot, and this will pull up a titration curve for this specific experiment. So as you can see, the y-axis will be your chemical shift, x-axis will be the molar ratio, that is all of the different spectra present here. And all of these different points will be the chemical shift of this particular residue I6H across all the different titration points in the experiment. And that is how you look at titration and perturbation plots. Thank you so much for watching.